The broadcast is now starting. All attendees are in listen-only mode.
Okay, hello everybody. Welcome to today's webinar. We're excited to have you all here for today's discussion about pedestrian and bicyclist crash types. We're going to hear from two agencies today that are looking closely at their data to understand crash types and to use that information to make important safety decisions. This webinar is being supported by the Federal Highway Administration's Office of Safety through a program led by VHB and the UNC Highway Safety Research Center that provides training and technical assistance to the FHWA designated pedestrian and bicyclist focus cities and states. My name is Dan Jeline and I'll be facilitating today's webinar. I'd like to go ahead and introduce you to each of the panelists joining us today. We're going to have two teams really today, a team from Florida and a team from Arizona. So our first panelist team from Florida includes Ilir Bejleri, Achilles Cortelis, and Mike Wilson. So Ilir is an associate professor and co-director of GeoPlan Center at the University of Florida. Achilles is a senior research associate at CUTR, the Center for Urban Transportation Research at the University of South Florida. And Mike Wilson is a transportation planner with the MetroPlan Orlando MPO. We're excited to have our team from Florida here to share some of the work that they're doing there. The second group of panelists from Arizona includes Michael Sanders, Brent Crowther, and Michelle Beckley. Michael Sanders is the Bicycle and Pedestrian Program Coordinator for the Arizona Department of Transportation and has managed the Bicycle and Pedestrian Program in the Arizona DOT's Multimodal Planning Division since 2004. Brent Crowther is a professional engineer working at Kimley Horn and has supported Arizona's Bicycle and Pedestrian Program since 2002. Michelle Beckley is a senior engineering designer at Lee Engineering, focusing on traffic analysis, safety, and ITS-related projects. I'm also joined here by my colleague Libby Thomas, who's a senior research associate at the Highway Safety Research Center. Among many other topics, Libby has a great deal of experience in pedestrian and bicyclist crash typing, and we're excited to have her join us for the discussion today as well. I would like to shift gears for just a moment and walk through a few housekeeping items for you all. If this is your first time on a PBIC webinar, welcome. Attendees, I'd like to ask if you can hear me to please click the hand icon that's located in the upper right-hand corner of your screen. That's going to let me know that you can hear me and the webinar is working and that all is coming through to you all. Great. Okay, I'm seeing those hands go up. Excellent. Thanks very much. If for any reason your computer freezes during the webinar, please just reload the website and log back into the program. You should be able to rejoin the session. I'll note, attendees should note that you won't have the ability to speak during the webinar, but you do have the ability to submit questions and comments to us using the questions pod within the GoToWebinar control system. Please feel free to ask your questions at any time and make your comments as we move along. We are holding about 20 to 30 minutes at the end for a discussion session once the presentations have concluded. A few notes about the archives. We've already put the PDF copy of the webinar slides up on our website. You can find it at pedbikeinfo.org/webinars. Just navigate to this webinar and find it at the bottom of the page. In a minute, I'm going to send the link out to all of you so you have a copy right there with you. The copy of the presentations is there. The webinar is being recorded and should be posted to the website within a couple of days. I may even be able to get it up this afternoon. That information, along with some other resources, will be coming to you in a follow-up email this afternoon. The important thing to note about the follow-up email is it will include a link to a page where you can generate a certificate of attendance for the webinar. So it's important to know if you're attending the webinar with a few other people in the same room, please forward that email and that link around to them so that they can also produce their own certificate of attendance. We've gotten the webinar submitted to and approved by the American Planning Association for 1.5 CM credit. So if you're used to claiming those credits, you can find the webinar in their event calendar online. If you'd like to attend any other webinars, we've got some going on pretty much every month. And so I'd encourage you to sign up for our mailing list, follow PBIC on social media, visit pedbikeinfo.org/webinars for the latest information on the sessions that we're planning. I do have a quick poll that I'd like to go ahead and take right now, and it relates to getting a sense of how many people are out there today. So I'm going to launch this poll here. We'll only leave it up for a little while, but we're really interested in knowing how people are attending our webinars. So let us know if it's just you attending from your site, if you've got a small group with you, 2 or 3, 4 or 5, or even a larger group. We'll only leave this up for a little while longer, and we'll get right into the presentations once we have a few more votes cast in the poll. So if you don't mind, take a look at that, cast your vote, and then we'll move right along into our presentation. Okay, I'm going to go ahead and close the poll now. Thanks everybody for voting. We really do appreciate the feedback. I'm going to kick things off really with my colleague Libby Thomas, as I mentioned, is here today. And we wanted to kick things off at a high-level look at crash typing. You know, what is crash typing really intended to do? Why do we need to type our crashes and understand crash types? And we have this initial slide, which many of you may be familiar with, this sort of year-over-year kind of rising number of pedestrian and also bicyclist fatalities. This graph here is showing pedestrian fatalities, but crash typing and really understanding crash types is really all about getting to that next level of detail within our crashes to make better safety decisions. Libby, did you want to say anything more about this slide here?
Yes, I'll just say that we picked these 3 years of data because 2014 FARs, the analysts at NHTSA have been crash typing the pedestrian and bicycle crashes. So that's why we only went back to 2014. But as Dan mentioned, you can see that rise year over year. Percentage-wise, it's been somewhat higher in areas designated as rural and versus urban. But because of the larger overall numbers in urban areas, they still count for the vast majority of pedestrian fatalities.
And we should mention right off the bat that this data is coming from, some of you may know, the Fatality Analysis Reporting System, FARS, data managed by NHTSA, reported up from the states, and that's where this is coming from.
One more thing I should have mentioned is that we included the other persons using other conveyances, wheelchairs, skateboards, and that sort of thing. And so in the statistics, NHTSA reports in the traffic safety facts, they don't include those numbers.
But if you drill in, I guess, maybe to some of the typing, you can really understand a lot more about the crashes.
Yeah, so FARs became interested in this because they see the value, or the folks at NHTSA did, see the value in understanding what, where, when, what are the crash patterns, because those really do lend themselves to identifying the right types of treatments. So we just took a look, and there are a lot of, there's some more crash types, but just to show the top 7 groupings of crash types include the crossing roadway, where a vehicle is traveling straight through. That's the top one of the in this table, and that represents 35% of all the fatalities in the database. The next type is one that you may be familiar with, and is especially in areas without facilities or sidewalks along the roadway or paths and such. And that accounts for about 13%. So you can see a few of the other top types there, and then all of the others besides that only accounted for less than 20%. So this top 7 group accounted for 83% of all the fatalities nationwide over the past 3 years. And then finally, we thought, okay, let's take that top type there and look at that in a little more depth. And so we looked at the roadway characteristics associated with that crash type. And so we found the vast majority, nearly 80% of those, are occurring at locations with no traffic control. So the pedestrian is trying to cross a road at a place with no signal or stop sign. And then what are the road conditions? What are the characteristics of the roadways they're trying to get across? Well, about 39% are two-way undivided roads with, I'm not showing the data, but 41% of those are at two-way undivided roads that are greater than 2 lanes. And so the other 3 types shown there are all larger types of roads, divided roads with painted and raised medians, and then also a substantial number on roads with two-way left turn lanes. You can see 22% of this set that occurred at uncontrolled locations occurred on those kinds of streets. That may not be surprising to many of you, but at any rate, it's important to take a look at that, so then we understand the conditions, not only the crash pattern, but some of the conditions that are present at locations, and that helps us hone in on the right types of treatments, not only treatments that might work at that location, but that are appropriate for these different kinds of contexts. So those are just a few of the roadway characteristics that we just want to illustrate how this information can be useful at a jurisdictional level. So and that's all we're going to say now, but we can take questions later on, and we have some other examples as well that we have used in various types of analyses.
Yeah,
I'll just turn it back to Dan.
Thanks, Libby. And that's a really nice, quick and dirty overview of how you might go from, looking at a total number to really getting more detail of your data and making better decisions. And so as I transition the screen over to our first team from Florida, and Aaliyah, keep an eye out for that, it's coming to you. I think what the big question is, how can we get a better understanding of our safety data beyond just the numbers? What are the details of these crashes and the resulting fatalities or injuries, and what's happening at the state and local level? And that's where the teams we have today are really going to dive into this topic. So Aaliyah, I don't want to take any more of your time, so please go right ahead. Whenever you're ready, I can see your screen.
Thank you, Dan. I appreciate it. So in our presentation for the Florida case today, we'll have three major topics to discuss. One, I would like to show you how we do our bike ped crash typing in Florida using a system which we're calling web-based PBCAT. Second, Achilles will talk about how we actually use that system to type our crashes, our bike ped crashes in the state. And then last, Mike Wilson will talk about a case study in MetroPlan Orlando, one of our largest MPOs, on how to apply crash typing safety analysis. Obviously, Dan and Libby already talked to you about the importance of bicycle pedestrian crash typing, and because of this need, FHWA and Libby's team developed the bike ped crash analytical tool, or what we call that typically PBCAT. So I'll be using that acronym from now on till the end. So that was developed quite a while back, and just wanted to provide a quick overview of that software. It's a standalone software, requires installation. Requires either keying the data into it or importing the data using templates. The data import will include matching the local fields that a state might have with the PBCAT fields. The tool is not integrated with GIS to run at present, requires Windows XP. And that's because it has not been updating quite a while, and in fact, there is no longer supported. So we took those consideration into account, plus the fact that in Florida, we have, unfortunately, a large number of bicycle and pedestrian crashes. And that's the information that our agencies and consultants need at multiple levels. But in addition, we have a need to share this data easily at those levels. On the other hand, we do already have a statewide web-based crash data system that's not just for bike ped, but for all crashes in the state. And therefore, having that and considering the existing limitations of the PBCAT, we decided that we're going to try to take a different path that will meet our needs better. So we essentially developed a new tool from scratch, but it's based on the current PBCAT for you that may be there and have used PBCAT or may have heard of it. So the PBCAT engine is the same, the method is the same, but we've developed a whole new tool. And essentially, this tool doesn't stand alone. Instead, is used as the plugin into our existing crash database system. By taking this approach, allowed us to enhance our system with this bike ped crash typing capability that's basically using the standard national method and making, therefore, this available to and easily accessible to all our relevant stakeholders, such as DOT, MPO, local governments, their contractors, and so on. So I'm going to flip my screen real quick here and give you a very short 5-minute demo, maybe 8-minute demo of the system. So what you're seeing on the screen is what we call Signal 4 Analytics. It's our web-based crash data system. And the data in this system it's showing right now, you see a map of the crashes in the last 3 days from 4/27 to 4/29. However, the system hosts data that are from since 2006. The system is web-based, is accessible to over 3,000 users across 400 agencies and 100 various consulting firms in the state. So we obtain this data daily from the state. We load it and map it, and this is what you get when you log in. I logged in just a little bit before we started here. On the left, you see a query panel here that allows an analyst to narrow to a much smaller data set of crashes of interest. The map shows crashes clustered spatially, and you can navigate this map by zooming in and out, and it clusters, unclusters as needed. On the left, we have the panel here that shows the various GIS data fields. So this is GIS-centric system. And then we have also integrated bar charts. For example, show the distribution by day of the week, since I only have 3 days of data showing right now. But if we switch the time of the day, and you see the distribution of these crashes. At the bottom, there is the data grid, which shows the individual crash records that are pulled at this time. So you can see that just for those 3 days, we've retrieved almost 950 crashes. Unfortunately, we got too many crashes in the state. These are all crashes. These are not just bike-ped crashes. The system, before I jump into that, I wanted to add that the system also include links to individual crash reports. For example, if we wanted to see the report on this particular crash, we have a link that pulls up the PDF, and then the analyst can look through the report, especially for bike-ped typing. For example, look at the narrative, look at the diagram, in order to then be able to establish a detailed bike-ped crash type. Let me narrow it down to the bicycle pedestrian crashes for this period. So we have a specific dedicated filter that allows that. So I'm going to choose only the non-typed, because we've been typing, using the system, we've been typing our historic crashes and trying to catch up with the crashes at present. But in the last 3 days, these crashes are not typed. So I am narrowing my search to just those 3 days and switch to a grayscale map. You can see those 18 crashes in there. Well, 3 are not mapped yet, but 15 are mapped. And then to be able to map them, you see that there is a column here that is called, basically shows a symbol, a P or a B, that shows whether that's a pedestrian or a bicycle crash. And there's a field here called bike-ped detail crash type. So you can tell that these crashes have not been typed yet. So for one to type these crashes, the way that our PBCAT web-based works is that an analyst will right-click on that P, click on bike-ped crash type, and it opens a whole new screen, which will look very similar to what you used to PBCAT if you used that in the past, but it's in a web-based environment. One important thing here is that to be able to type a crash, you need the police crash report. So we have a little switch here that if you turn it on, then it will show the police crash report for that crash. Normally, our analysts have 2 screens, so under different circumstances, I would move this to the other screen, and therefore I can see both my steps to take me through typing, as well as the report on the right, which then I can consult at the same time, be able to make these decisions. So I'll walk through a series of steps here. I'll make just some choices, may or may not match that report exactly, but because we don't have a whole lot of time, just want to demonstrate this. So this is defined as a pedestrian crash based on what's on the database already. And then here we'll pick some of these available options. So in this if this crash occurred to intersection, then I'll pick intersection. You'll notice then as soon as I pick, it will move to the next question automatically, because we've set this auto advance to on. This is for efficiency. And then I go through the typical questions that eventually would lead to defining a crash type. So say the movement was in the southbound. By the way, here's the report. And here's the diagram, so that could be useful in establishing that along with a narrative. And then we had a straight through movement in the near side of the intersection, and we had pedestrian within crosswalk traveled to the motorist right. If there are unusual circumstances, I'll choose them, but I'll go with none at the moment. Unusual vehicle type or action, say none at the moment. And then pedestrian was unusual pedestrian action, none. Just trying to skip these for the sake of time. Say the pedestrian was crossing in the roadway, and then the pedestrian dashed in front of the car. So at the end of this question, it comes back and defines a crash type, which is dash. I think that was one of the crash types that you show in stats that Libby showed a little earlier. And then you've got access to all the path that was determined, was used to determine that crash can go to any of these at any time and make changes. And then notes can be added to at the end, and then an analyst would accept and save. It will automatically move through that list of those 18 crash types and allow the analyst to type those crashes. So the beauty of it is that once they are typed, and I'm not going to do that right now, but once they're typed, then all these the information here will be turned into green. These circles would be green, and the information here in a bike ped detail crash type will be whatever was typed at. So instead of doing that, I will go and pull some historic data that already have been typed, say January 1st, 2015. 2015, and then over here I will pick, instead of non-type, I will just say pick only the pedestrian crashes that were typed, and then you can narrow it further down. For example, if we wanted to just pick those that had a crash severity of some injury, for example, you can pick only those 3, or you could pick all of them, or you can only pick fatal crashes. I know that we've been trying to type these crashes, but we haven't done all of them, so I'm just going to pick a narrowed set. So you can see 684 crashes that have been typed, and then you would see most of them have been typed. You see the P's in here, and if I scroll over, then you would see the detailed crash type. It shows only the detailed type. However, the tool produces all the PBCAT fields. In fact, there is a little button here to, if anybody wanted to export it to do further analysis into a third-party software, then it can export the data. So it will include the bike ped crash typing or in the GIS format, because these are also mapped. And therefore, if I hit OK, we'll produce that export. Let me avoid doing that just in the interest of time. This is what it would export as far as the CVS file. So you could see, if you're familiar with PBCAT, you relate to these fields. If you aren't, this would be good information to know what that tool is able to produce. So you got the group number, the group description. These are some of the ones that we're showing in the statistics. And then even more detailed crash type, location, and many other information related to that particular, to these crashes. So you could do further stat analysis in here, or you can do analysis of these crash types by going within the system directly. And we already have various attributes that can be chosen here to look at, for example, the severity, or whether there was an alcohol related or not. We have 2D charts that show distribution of crash type and crash severity. I will stop here with a demonstration and then switch back to my slide. This was just to give you an idea how the system works. So we see a couple of major advantages with the web-based version that we developed. First of all, the engine to create these crash types, it's quite involved. There's almost 350 crash type altogether, and there are complex paths on how to get to that crash type. So as analysts answer those questions, then they basically ultimately determine the type, but it could take multiple directions, as you saw, depending on the choices that you make. The advantage of the web-based engine is that it's in one place, and as a single server-based engine can then be easily updated, and it can also be transparent to the user. Because this is web-based, all you have to do is just log in and say if the If the engine or the crash types were enhanced or expanded or modified, they would change in one place. The user won't see it. They just get the updates simply due to the fact that it's web-based. Another advantage is that the way we developed is that it has this web-based client interface, which allows you to then link to an existing local crash database as well. And as such, we see this PBCAT as a service, which means as a web service, which means it can be plugged into other crash data systems. For example, in here, we're showing a conceptual diagram. On the left, you may have different crash data systems, say, for example, from another state or other states. And then the web-based PBCAT would communicate with them by first obtaining crash report ID. That's all it's needed, more or less, the crash report IDs and the crash reports, their images or PDF format. That will give the analyst access to what I just demonstrated. And then in return, the web-based PBCAT will return the detailed BikePet crash typing, which then would be recorded in that system. So with that, I'd like to pass it to Achilles, who will talk about how we used this in the state to do our BikePet crash typing.
Thank you, Ilir. So as Ilir mentioned, DOT was interested in actually using PBCAT and the crash typing details to look further into factors that obviously contribute to the crashes, and as many are realizing now. And the funny thing is that PBCAT has existed for years before. It just was not updated, especially after Windows 7 was introduced. So when we started the project, that DOT was interested in typing 5 years worth of all pen and bike crashes. Next slide. And this was back in last year. So we actually started by series of crashes. We started actually typing fatality crashes first, both pen and bike, then serious injury, and then the possible injury and property damage only. So to date, we have typed the numbers that you see there. All these crashes are already in the system that Ilir mentioned. The difference is that when we started the fatal crashes, we were actually working on the standalone PBCAT software that was produced by UNC. By the Pet Bike Info Center, and we had to use virtual machines. It was fairly clunky. It did have some issues. But at the end, through the progress of Ilir's team, we were able to use the web-based, which is much smoother, and it works to the advantage of the analysis part at the end. What you see here is separately left and right pet crashes. I'm going to just show some fairly basic details in the next slide. So here we have the crash group first, which is the kind of the basic detail that you get first. As the name says, is a grouping effort where you each of these rows, for example, the crossing roadway, vehicle no turning, does have multiple sub entries, let's say, and that's the detailed crash type, which is not visible here, obviously. But you see, so this is for serious injury only for the state of Florida for the 2011 to 2015 year range. And I mean, we can see kind of things we expect and some things we don't expect. Also, from this effort, we were able to identify the ones that are maybe not represented very well in the crash reports. And we can also see pedestrian position. Clearly, most of them happen on a roadway in a travel lane. That's where people cross. Obviously, that's when they get hit. But you do have many that happen in non-roadway areas that include parking lots or driveways or things like that. And then the other thing that's really important is the fact that people do get hit. I mean, the third one is crosswalk. So marked or unmarked. I mean, the idea that we're directing people to cross at the crosswalk, but then they get hit there is very important. And also we have crash locations. Now, obviously, we're not showing everything here. I just did put the most important basic information. A crash location is another one where you have basically non-intersection location and in non-roadway location, the biggest ones. But we do have some intersections, again, where we expect people to cross. And then I think the next slide does have information on the pedestrian movement. So this is another important one because we can tell, actually PBCAT asks for two types of information for pedestrian. They ask for their movement before the crash and what the action of the pedestrian, right when they were hit. So it does give information as to how they reacted and what did they do. And as it also gives information for the driver as well, which again I didn't include here because it is a lot of information. You have to do a fairly detailed analysis to get into the details. And actually Mike is going to provide some of that in a little bit. And things that we also do, and we can use, this one wasn't produced by the software that the signal for that earlier showed. It was, we exported it and just used GIS to do it. But the idea is that you can create, obviously, cluster maps, analysis situations. This was just a basic overall for the whole Florida cluster map we created. It's a static image, but we also have an application online where you can zoom in into an area you are interested in and everything adjusts so you can see where you have these clusters of frequent crashes. The next one is bicycle. Very similar information. However, it is obviously different typing. It's a different grouping and typing. As we see here, motor is failed to yield is obviously number one here. The first three types. And then you go to the bicyclist failed to yield 8%. So this is important because many people think that if you don't have this information, think that bicyclists are the ones to blame. But clearly we can see they're not, the majority. Also, we can see again location, intersection obviously is where most of them happen, and then so it's almost half and half there. Non-intersection 42%, and the idea is to you can actually identify these locations. Again, if you use the maps and the type, you can kind of tell where crashes happen, and having this information, you can know why they happen. The position of the bicyclist is another thing that is important, and the first one is sidewalk, crosswalk, or driveway crossing, so it's not in the roadway. And this is where most crashes happen for many reasons, as many of you know. But then the second one is on the roadway in a shared travel lane, and we actually found that most of the bicyclist crashes in this is because people cross the road with the bicycle, and that's when they get hit. Not necessarily while they're driving in a lane, just going. That's actually the third one. And I think the next slide shows the map. Yeah, so similarly, we were to create maps for, this is a cluster map for bicycle crashes. As you can see, Key West is actually the number one, and you have a lot of rental bikes there, and that's why it's a big one there. But the idea is that you can actually do many things, and the state safety office has decided that this is important. They did invest to type. So far, we've typed up to 2015, but we are looking to continue and including the more recent years. And I think that's all I have, and we can continue with Mike. Yeah.
Okay. Yeah, this is Mike Wilson, and with MetroPlan Orlando, we are just getting ready to kick off. We've actually just started kicking off our pedestrian and bicycle action plans, and I've been doing a lot of deep diving into the data. Ilair, if you want to go next. Next slide. As with the rest of the country, we were seeing the big increase in pedestrian fatalities, which is far exceeding the increase in injuries. Now to get a sense of what's going on with that. Next. And the type of crash that we see the most of, that pedestrian mid-block failure to yield, has only gone up about 16%, while interestingly, the motorist failure yield has gone up at a much greater amount. But when we look at fatalities, next slide, things change quite a bit. Here, the pedestrian failure yield increased nearly double over the first 3 years and the last 3 years of our study area. By the way, we've got 7 years data for our study from 2011 through 2017. And but what's also interesting is during that same period, the motorist failure yield, while there were smaller numbers responsible for the fatalities, was a much greater increase. But I want to know what's going on with these failure to yield crashes and why were they increasing. So I looked at the lighting conditions, and we saw that only a small proportion of them happened during daytime, 20%, nearly 50% on unlit roads, but 165% on lit roads. And remember, that's in respect to a 44% overall fatality increase. So this is what's responsible for the lion's share of our increase, and kind of implies that it may not be an increase in exposure, because why would we only have an increase at night and not see a similar increase during daytime hours? And this data also allows us to ask some questions that we've kind of mused on as professionals for many years, such as, is it really safer to cross at the intersection or mid-block? Well, when we cross mid-block, obviously we only have a couple of conflicts to worry about, whereas if we went down to that nearest signalized intersection, we'd have all those driveway crossings, unsignalized intersections as well. So I was able to do a comparison, in this case looking just on the state road system, at how many pedestrian failure to yield at mid-block locations compared to motorist failure to yield either mid-block or at the intersections. And you can see it's a little bit higher actually for the motorist failure to yield. Again, this is looking at all injury levels. This would shift if it was, if you could stay back with that. If you could go back to the prior slide. Yeah. If this were shifting toward fatalities, it would be shifted a lot more toward the pedestrian failure to yield. But then also notice the flip between daytime and nighttime, that for daytime hours, it's more likely to be motorist failure to yield, and at nighttime, it's the pedestrian. So this then leads us into questions about, well, rather than perhaps telling people to go to that nearest signal to cross, how do we make that mid-block crossing safer? And we'll also be looking at exposure. We're going to be doing counts, mid-block and signal counts, so we can get some sense of the true relative risk. Next slide. And then moving into the bicyclist things, here we're seeing a big shift in who's causing the crash. The motorist caused crashes increased a great deal over those first 3 years and last 3 years. You can see about 200 additional crashes, with about 3/4 of those involving cyclists using sidewalks, paths, or bike lanes, and the remaining quarter cyclists using the roadway. And then bicyclist caused crashes actually dropping somewhat, and the majority of those reduction involving cyclists using the roadway or the bike lane. Next slide. I also wanted to look into this concept of safety in numbers. And if we're talking about bicycling, for example, if we have a road with a bike lane, shouldn't we be seeing a reduction in motorist caused crashes, at least in relation? Well, I had 70 miles worth of roads that had bike lanes, and compared those to a similar number of miles of comparable roads, and I tried to compare control for number of lanes and posted speed and land use. And here you can see that it's the motorist caused crashes that went up by 124%, while cyclist caused only went up by 33%. And if you want to look at the non-bike lane streets, it was actually flipped. Although the numbers are fairly small here, we're only talking about 3 additional or 6 additional crashes. So if that safety in numbers premise that it's the motorist behavior that changes is brought forth, well, this is not reflecting that. This is actually suggesting that it's actually the bicyclist behavior that's improving, perhaps because more cautious bicyclists are being brought out, invited out to the bike lanes. And here we drill down a little deeper into the types of crashes that are involved in the bike lane and non-bike lane streets. And see not a whole lot of difference between the overtaking motorist crashes, but it's in these turning and crossing movement crashes, the drive outs, the right hooks. We see a big increase on the bike lane side and actually a little bit of a decrease on the travel lane side. Also note the wrong way cycling crashes, a big increase on the non-bike lane streets, but fairly small numbers. But overall, more wrong way cycling on the bike lane streets. Next slide. So, as I mentioned, we're getting started on our safety action plans. And what I want to do with this crash typing data is create a better connection between the crash types and the countermeasures that we pursue. We've been going after this, using this 3E approach for decades, of engineering, education, and enforcement. And I'm reframing this as looking at countermeasures from the standpoint of, are they design-based, are they behavior-based, or are they control-based? And this way, it gets a little more specific, particularly on the behavioral ones, that it's not education that is the countermeasure, it's the actual behaviors that people put into place out there in the real world. Next slide. And so the process that I'm taking with this is that we start off with our crash types and the proportions of the types that as they show up in our data, and then identify critical success factors for the crash types that they fall into 4 broad categories, and there are more specific ones under each one. And for each crash type, you should have success factors that are going to be the ones that are going to improve those crashes. And then we take the countermeasures that we have in mind, and we look at, do they improve these critical success factors, which then in turn reduce the crashes? And also, are they internally consistent? Do we have design changes that are consistent with the behavioral change that we want to see? So that's the basic model of our action plans, and we hope to have them done by the end of this year. Thank you.
Great. Well, thank you all so much, Ilir, Achilles, and Mike. That was awesome. We really enjoyed learning about that. I'm going to continue to accept the questions that are coming in. There are a lot of good questions and comments, and hold those for our discussion period at the end while I move into our next presentation. And so I'll take the screen for this next part of the show, which is going to come from our team in Arizona. We'll hear about what's going on there, and then we'll bring it all back together for the Q&A. Michael, Brent, and Michelle, whenever you all are ready, please go right ahead and just let me know when to move the slides forward.
Okay, thanks, Dan. Michael Sanders here, Arizona Department of Transportation. Good day, all. Today, we're going to share with you our method for assigning crash types to pedestrian bicycle crash data and how we're using this information to make recommendations through our safety action planning efforts. And I want to acknowledge our FHWA division office, because they have provided the funding through the State Planning and Research Program to do the action planning. And we've been involved in this for about 10 years now, Brent and I. And more recently, Michelle and Mike Sinecki with Lee Engineering have joined in getting some updates to our planning. Next slide. Okay, so this is kind of the framework for the action planning. As I mentioned, we're in update phases now. So the first step that we've been taking is to look back at prior recommendations and come up with a list of what worked, what didn't work, and try to incorporate that into our updates. So our focus is the state DOT highway system. And so we've collected crash reports for 5-year periods for our action plans. And, we're focused on our system, the main streets in communities across the state, freeway interchanges, and in those rapidly growing suburbanizing areas that are transitioning from rural to urban cross-section highways. And again, this is a planning level study, so the recommendations, the potential countermeasures that come out of this effort are subject to further engineering review. We make that very clear that that's going to involve more site-specific analysis, field review. And our plans are intended to supplement the ongoing strategic highway safety planning efforts going on in Arizona and the highway safety plan through our Governor's Office of Highway Safety. Next slide. This map is showing you a plotting of pedestrian crashes for the most recent 5-year period that we had looked at. That was 824 crashes in the 5-year period. And we recognize that both for pedestrian and bicycle related crashes that those crashes occurring on the state highway system is a relatively small percentage of all crashes. And the other point to make here is that, we have collected the reported crashes submitted to our traffic records safety section. You'll notice, though, that we do have the cluster in the Phoenix metro area, center of the state, and then to a lesser extent in Tucson and some of the other metro areas, not surprisingly, because that's where pedestrians and bicyclists are most frequent. You also notice the beige shaded areas on the map. Those are our tribal areas. And we know that we're not getting all of the reported crashes occurring, or perhaps they aren't even being reported on the tribal lands. So to assist in identifying those areas of concern, we've actually reached out to all of the 22 tribes in Arizona and asked them to give us information about where they feel there are safety problems on the state highways on tribal lands. And we actually have another project underway to assist in getting better reporting from the tribal areas. And we've also done a number of road safety audits on state highways within tribal areas over the years. Next slide. So we did our first action plan, the Pedestrian Safety Action Plan, back in 2009. And for that document, we crash typed using PBCAT all of the crashes that occurred at identified high crash locations. Now, we also had done a public survey with that plan, asking people to tell us about the pedestrian safety problem areas in their location. We updated that plan in 2017. We'd also completed a bicycle safety action plan in 2012, where we did crash type all of the reported crashes on the state highway system. We also did a public survey with that plan, and we're now in the midst of updating that 2012 bicycle safety action plan. Now, the beauty of the crash typing too is that it then allows you to tie into directly with FHWA PedSafe, BikeSafe countermeasure selection tools. So that's one source of, once we have identified the crash types, come up with a menu of potential countermeasures. Those are valuable sources for us to use. Next slide. So basically the process, collecting the reports. fortunately, since 2012, all of our crash reports are now accessible online, so we're able to pull those reports fairly quickly and then get into the crash typing process. What comes out of this, though, as part of our safety action plans, we're identifying the high crash locations, the hotspots. But with the updates, we've also been doing a risk assessment. We know that pedestrian crashes, bicyclist crashes can be fairly random. You know, for example, in the Phoenix area at freeway interchanges, one year it might be one freeway location interchange. The next year, the one down the road. You know, so we've kind of grouped them by traffic interchange type, whether it's a single point, conventional diamond, and started to look at how we can make recommendations on changes to types of interchanges. But with the risk assessment, for example, on the pedestrian side, we got into a fair amount of detail in terms of, you know, coming up with some factors, you know, based on the crash data, but, you know, roadway geometry, number of lanes, traffic speed, traffic volume, and then also looking at land use, those types of land use that would generate pedestrian activity. So, you know, that's part of our action plan too. It's not just the crash data, but also looking at other areas, trying to be proactive to prevent crashes from occurring. So at this point, let me turn it over to Michelle Beckley to give you some of the details on how we crash typed bicycle pedestrian crash data, at least over the past couple of updates.
So for the next portion of our presentation, we're going to be getting into the crash typing process. So we will go through from start to finish how this would work for a few examples. And I'll go over where you can find all of the crash typing information that was produced in the PBCAT manual from the Federal Highway Administration and the Highway Safety Research Center. So it all starts with the crash report. I've shown this as just a visual so you can see what types of fields are on the Arizona form. There's information on each unit and the manner of collision. And these are standard fields that are pulled directly into the web-based tool that was created by Kimley Horn. So what's especially important in crash typing is to go into more detail, as others have mentioned, and this includes the officer's narrative and the collision diagram, which is very important. So one thing I want to point out on this slide is that there's actually a field on the bottom right-hand corner that describes the position of the pedestrian or bicyclist. So when that field is completed, that's helpful as well. As I mentioned, the PBCAT manual that was developed as a guide for this crash typing process is very helpful. It explains how an agency would create the field to be tailored to their crash report form and how the data would be entered, and some reporting options that are built into the original PBCAT software. So as the Florida team mentioned, they created a web-based tool. For these projects, we've also created one as well. It was developed by Kimley Horn, and I'll show that in a few slides. But due to the large scale of the pedestrian safety action plan and bicycle safety action plan updates, there's about 800 crashes that we reported for, that we entered data for each one. So it was important to have multiple staff members included in this process. And as was mentioned before, it's a lot more helpful on a web-based platform rather than a standalone process where it's really one user at a time. So with that, if we could advance to the next slide, to supplement what was developed for the PBCAT manual, we created an internal document that is a little bit more tailored to the fields on the Arizona Crash Report form and what we're specifically looking to do for both safety action plans that were mentioned before. So, you know, this document was mainly for consistency between the multiple staff members included in the data entry process. A few things to mention. There were a few reasons why I wanted to exclude certain crashes. For example, if they weren't related to the state highway system, or if there was maybe a officer coding error with either pedestrians or bicyclists, if they were coded as other units, we take those out. It's kind of a quick guide to match what we need in the crash typing software to where it is quickly on the Arizona Crash Report form. And then one more example of what this would cover is we decided at the beginning of these projects that we wanted to code the crash typing and a few relevant roadway features. For example, the classification of the roadway, the geometry, and the lane width. This is from the perspective of the pedestrian or bicyclist rather than the motor vehicle. So with that, we'll go to the next slide. And Brent, if you're on the line, if you want to give some more information on the PBCAT tool.
Sure, Michelle. For the reasons cited previously, we wanted to use the PBCAT, but had not been updated to today's operating environment. And so we had our team internally, our software folks, basically extract the same framework, the crash types, the group types, etc., and convert that into a web-based platform. And that enabled a couple of advantages, primarily that we could have multiple people doing the entry from whatever site they are. So Michelle and her team were doing some of the data entry, as well as some of the folks within Kimley Horn. We had a username and passcode protected that would record who was doing what each of the crash types, so we could have that tracking mechanism. But it really allowed us to use that PBCAT platform, bring it up in today's operating environment, web-based, which made it very much more convenient than having the single PBCAT software on a single machine and having to figure out how to load it with XP and et cetera. So really made it more user-friendly for us.
Thank you. So I want to draw attention, if you could just go back one slide, the information from the crash report form that is very easy to transfer. This is for most of these fields. You'll see there's the location, roadway features, some environmental conditions, and then information about the driver and the either pedestrian or bicyclist. But the focus of this presentation is geared towards the bottom right-hand field, the crash typing. And this is where we're looking for a little bit more qualitative information of what really happened and the situation in which the collision occurred. So with that, we'll go to the next slide. And so this is the first example that we've prepared. This crash occurred on a Tuesday afternoon in September 2014. There was a male and female bicyclists traveling from Tucson, Arizona to Flagstaff. This is a 72-mile ride, and you can see that they were about halfway through their ride when the crash occurred. It's noted with the red dot. and this was on State Highway 180. Next slide. We can see that US Highway 180 is a 2-lane roadway. You'll see that the shoulders are fairly narrow. So in this situation, it's fairly reasonable to assume that bicyclists would be riding either along the edge line or within the travel lane. So in this case, the bicyclists were riding single file, one after the other in the eastbound direction. A motorist is approaching in the same direction from behind. The driver does identify the bicyclist, attempts to pass, but strikes the second bicyclist. The second bicyclist did sustain fatal injuries, and the first one was not impacted. So when we take all of this information, we'll go to the next slide in the crash typing. And the crash typing in the web-based platform that was created, it's a series of 5 fields, and based on the choices that are selected, it can narrow the subsequent options. So the first one is crash location. This is clearly on a segment, so we identify this as non-intersection. Next slide. There are many crash groups. I'll show you some in the tabular format of the PBCAT manual, but this one would be coded as the motorist overtaking bicyclist. The next slide. So because we've selected that option, we're now narrowed to these 4 choices. They're either an undetected bicyclist, misjudged space, the bicyclist swerved, or other or unknown. So based on the options provided, this is most closely fitting to misjudged space because the bicyclists were detected. And then in the next slide, we're defining the bicyclist position. So based on the information in the narrative, the riders were in the travel lane. And lastly, in bicyclist direction on the next slide, they were riding with traffic. So this is an example of how we'd complete the crash typing for that example. We'll move on to the next slide. These are images from the appendix of the PBCAT manual. So this is where you'd go if you have any questions of the right choice to select. It has a lot of information, and it clearly defines how they're determined. So I just want to highlight that the selections that we made are also found in these tables. So in this case, again, we've selected non-intersection in the first table. The second table is the bicyclist position, and we've selected the travel lane. And we'll go on to the next slide. So these are the 21 main crash groups. It's important to note that these are specifically for bicyclist crashes, so there's another set for pedestrian-related crashes, but we've selected 230, which is the motorist overtaking bicyclist. The next slide. So all of the tables that you see on the right, the 6 tables, these are all of the possible bicyclist crash types. So these are smaller subsets of the crash groups that we saw in the previous slide. So in this example that we've discussed previously, we had the 4 options. You can see them in the blow up from 231 to 239, and you can see that we've selected 232, motorists overtaking misjudged space. So all of this is basically built into what was the original PBCAT software and also the web-based platform developed by Kimley-Horn. We'll go to the next slide. I wanted to provide a little bit more information about how the decisions are made. And this was brought up in the previous Florida presentation, but the PBCAT manual and the original PBCAT software have developed a lot of these great visuals that pop up when you're making the decisions in crash typing. So these figures were incorporated into the Kimley-Horn web-based tool. And so I just want to point this out that this is another way that supports the decision-making in crash typing. Next slide, please. So this is the second example. This is another bicyclist crash. It occurred on a Tuesday afternoon in October 2014 in Tempe, Arizona. This crash occurred on the off-ramp of State Route 202 and the intersection with Scottsdale Road. And I've shown this map on the right so you can see the proximity to the university. And this is an area with a fair amount of bicycle traffic. Next slide, please. So here's a closer aerial. You can see that the State Route 202 and Scottsdale Road interchange is single point urban interchange, and it is signalized. You'll see that the right turn lanes as they approach the intersections are yield controlled, so they operate independently of the signal. And so in this case, there was a eastbound to southbound motorist who was making that right turn. You'll see the bicyclist was traveling northbound on the west sidewalk, so they were facing traffic. They are continuing north through the crosswalk. My guess is that the motorist is looking for that gap in southbound traffic. They're not continually looking for the northbound bicyclist. So when the northbound bicyclist continues through the intersection, that's when they were struck by the motorist. So we'll go on to the next slide for the crash typing. Based on the choices, this was an intersection crash, so we coded it as such. We'll go on to the crash group. So although this intersection is signalized, the interaction in the right turn lanes is actually sign controlled with the yield control. So we've determined that, and then we've selected this as the motorist failed to yield. So that's how we determine the crash group. Looking further into the crash type of this particular crash group, we have two options, and in this case, it's focusing on the direction of the bicyclist in context of the motorist. So you can see in the first one, this is called motorist drive out. And in this case, the bicyclist is facing traffic, and in the second one, it's riding with traffic. So in this example, we've selected motorist drive out. And then for the bicyclist position, they were traveling in the sidewalk or crosswalk. And lastly, for the bicyclist direction, they were facing traffic. So these are two examples of how we'd move through this process. If you go on to the next slide, I just want to highlight where these selections can be found in the appendix of the PBCAT manual. We'll go on to the next slide. This one is selected as crash group 140, motorist failed to yield in a sign controlled intersection. And on the next slide, we are blowing up the box, that the table that's relevant here. And so in the options, we've selected 141 motorist drive out sign controlled intersection. So this goes through the process of how you complete the crash typing for two examples. And so in both the pedestrian safety action plan and the bicyclist safety action plan, these were completed for over 800 or approximately 800 crashes each. So when you're finished with all of the data entry, this is really helpful in identifying trends and factors that may have caused these collisions. And so this is helpful in developing safety countermeasures. And so at this time, I'll pass it back over to Brent to talk more about what we did with the data after it was all entered.
Sure. Thank you, Michelle. So if you go to the next slide, similar to what you saw in Florida, you can see that a high percentage of the crashes can be focused to just a few different crash groups. And this slide here is showing those crash groups for pedestrian crashes, and 59% of our crashes are accounted for in 3 crash groups: the crossing roadway when the vehicle is turning, crossing roadway when vehicle is not turning. And then I think this next one was probably our biggest surprise, the unusual circumstance. And the definition of this is somebody, for example, who is changing a tire on the side of the road, is outside of their vehicle and is struck as they are acting in effect as a pedestrian. And that is accounted for in that unusual circumstance. And we had about 15% of our crashes within that category there. And then if you go to the next slide on that shows bicycle crashes, crash groups descriptions for the bicycle crashes, not quite as high as our pedestrian, but we still had almost half of our total crashes are comprised of in 3 crash groups. And the highest was our bicyclists failed to yield at a signalized intersection. And then the second and third highest were on the motorist behavior, a motorist right turn, and a motorist failed to yield at a signalized intersection. And that motorist right turn merge, that's what commonly is referred to as a right hook crash. And then the motorist failed to yield at a signalized intersection, red light running, etc. When a bicycle was heading out into that intersection. You go to the next slide. What we did with that, our ultimate goal was to identify countermeasures. So our basic countermeasure selection process included digging into detail into those sites. We looked at those details as we were doing the crash typing. We read the police narrative. And then during this phase, we accounted for other available GIS data, looking at the ADOT photo log, which is a video history of the entire state highway system, utilizing available Google Street View imagery, looking up record drawings, recognizing what the street width is, presence of sidewalks, posted speed limit, etc. And then identifying those potential countermeasures based on a variety of sources, including PedSafe and BikeSafe, as well as others from national best practices. Examples of countermeasures include intersection modifications that could be reducing the turn radii at those ramps, which would slow vehicle speeds as they come off the off-ramps, crossing treatments, which could be pedestrian hybrid beacons, enhancing our signalized crossings. We also have some recommendations for lane reduction, otherwise referred to as a road diet, or narrowing the width of the travel lanes, as well as reducing the speed limit. Some of the more common ones, completing sidewalk gaps, or in Arizona, we have a lot of urbanized areas that don't have sidewalks because of ADOT is not able to fully maintain those sidewalks without local jurisdiction cooperation. And we also recognize that many of the countermeasures are not just engineering focused, but need to also improve pedestrian and bicyclist behavior. So recommendations to invest in education campaigns. Some other countermeasures, access management, would not only improve pedestrian and bicycle safety, but have an overall improvement on vehicular safety. And lastly, we recognize that within the scope of our project, we can't get into every detail and perform a complete project assessment for all of our locations. And so we have recommended it at many of the locations that we are preparing roadway safety assessments that focuses in more depth on those particular segments and intersections that we have identified through this process. So the next slide in conclusion, from our experience here in Arizona, The crash typing did provide tremendous insight to our identification of the most common factors and behaviors that lead to pedestrian and bicycle crashes. And we established a process that connect those factors to countermeasures that the anticipation is that they most effectively address the crash types. We went through a process that we haven't identified here where we were able to prioritize those countermeasures based on their crash modification factors and utilizing the highway safety manual processes to help us identify what the benefit of those recommended countermeasures are. So with that, Dan, we'll turn it back over to you.
Okay, thank you all so much. And very quickly here, I'm going to put a slide back up on our screen to guide our Q&A. What I've got listed here is some contact information for our panelists. In the event that we don't get through all the questions, which we may not, please reach out to us or to them. We'll hopefully get your answer to you one way or another. But what I'd like to start with is first a question about, this one actually came in more than any other question, and it's something I'd like to pitch to our Arizona team and also to our Florida team and ask, what is the requirement and the number of staff hours that it requires you all to do this? And, I mean, it's really impressive, and the systems that you've built to do it are great. What are you looking at in terms of the time it takes to go through maybe a year of crashes and type them using your systems? Could you ballpark that, or have you had to estimate that before? I guess I'll start maybe Ilir and your team in Florida.
I think Achilles can speak about this. Also can Mike, because Mike has done a lot of it.
Yeah, this is Achilles. I would say that at this time, we have a team that obviously has gone thousands, and they can process somewhere between, I would say, 18 and 25 reports per hour through the system as you saw it. And of course, each report requires that you read the few pages of information, look at the diagram, and make a decision and type it as you go. So that's what we found so far.
Mm-hmm. Okay. What about in Florida?
That's
I'm sorry, in Arizona.
You mean Arizona? Yeah, sure. Yeah, this is Brent. I can take that one. We estimated about 15 to 20 minutes per crash. And did I hear Florida did 15 to 20 per hour? Is that what I heard you say?
Yes.
18 to 25 per hour.
Wow. So we must be slow here on the West. But yeah, our experience to review the narratives, read the police, the narrative, and spend the information and the time we needed to gather the additional data to crash type it, we were averaging probably about 15 minutes per crash. And the system itself to convert from the PBCAT to the web-based, we did that pretty quickly. That probably took us, our software folks, probably about a week and a half to 2 weeks worth of effort to get that system.
And Brent, if I could add on to your point, I think there's a couple differences between the two systems. And for the web-based platform that was developed on the Arizona side, it has a great deal of crash report detail that is just basically data entry. So before you even get into the crash typing, all of this information either needs to be verified. If it was directly pulled through the database, it needs to be verified, or you need to enter more of these fields. So I think the difference in the time is just due to the maybe additional detail or additional are on the Arizona form.
Okay. Yeah, that's a really good point. And I'm wondering. I'm sort of encouraged, I guess, by the time it took. It sounds like, Brent, to turn that system into an online platform. And I know there's talk about, a lot of questions coming in too about the PBCAT system that many may be familiar with, the national system, the FHWA funded platform. That is a little dated now, a few years old. And so I wanted to ask, Tamara Redman is on from the Federal Highway Administration. And Tamara, I wonder if you have any sense of the current status of PBCAT and maybe what may be coming for it down the line?
Well, we would like to update it. I think there's a planned update to possibly take place beginning next year. I'm not sure when it'll be completed, but we are interested in getting feedback from folks, who might possibly use it, what they'd like to see in a new version, if possible, and any other feedback we can get that would help shape the new version to make it better and used by more people.
Yeah, thanks, Cameron. We'd certainly be interested in hearing from anyone out there who's interested in doing some of this crash typing, if you might be willing to weigh in on some of your preferences for that. But I heard a few comments throughout about, we've got our police crash reports that we're using to type the data, but then there are sort of other sources that we're looking at using. Maybe those are things like Google Earth or other information outside of the crash report. And I wonder if maybe the team in Florida or in Arizona would like to weigh in on what are some of the other, when the analyst is looking at the data and looking at the crash report form, what are the other resources or other pieces that they're pulling in when doing the typing?
I could speak very briefly about the Florida system. I didn't get a chance to show it here, but for every crash, you can zoom in to the site and look at the aerial photography. And then just within it, you could put the Google Street View. It's all integrated. So I know that's a sort of additional source along with the crash report that can be used. And I'm not sure if Achilles and Mike have additional information.
I'll leave it to Mike if he has any, because he's done more actual analysis than us.
For some analysis have actually tied the crash data to our roadway condition layers from NGIS. So links those crash plots, and so we kind of pull in the pedestrian and bicycle conditions, sidewalk coverage, lane widths, etc.
Great, thanks for that. And I wanted to ask a question of the Arizona team. As you were going through your crash typing exercise and you're continuing to do that, did you come across or have any opportunities when you were doing the crash typing to maybe look at data that could have been possibly incorrectly reported from the forms? Did you come across anything where you said, oh, well, actually, based on the narrative, I'm actually seeing that this crash was miscoded as a pedestrian where it actually was a bicyclist, or other areas where you've actually been able to use the typing process to improve the original data upon that? A lot of questions about whether the typing can actually correct for some errors that might be made in that initial report.
I can start with that answer. I think that so the data was, a big amount of data was directly imported into the PBCAT software from like a huge spreadsheet. And so this is the data that I was saying that we'd confirm. And so there were times where based on the whole picture and based on the narrative, there were a few fields that were either seemed incorrect or a better choice selected. So in that sense, they were modified as needed. I think it's important to, respect some of the choices that were made for those that were present at the time the crash report was written. I think for those that have experience in crash report review, a lot of times you can easily pick out some of those errors, so they were corrected as needed.
Thank you. And in Florida, getting at the same question, I guess, from your perspective, the typing from some of the comments we have coming in is only as good as maybe the crash report that you're working with initially. So I wonder if through the crash typing process, you were able to maybe identify any areas where the reporting itself could have been improved, or where you maybe weren't seeing the data you needed to properly type the crash in the first place. Any conversations like that have happened, or efforts to improve the reporting as a result?
Yeah, this is like, go ahead, Mike.
Yeah, it's one of the things that I'm seeing is a lot of crashes that are coded as pedestrian, where there was no pedestrian involved, and it was really like a parked car that was unoccupied, and the owner of that vehicle is listed as a non-motorist. You can kind of screen for that by looking at no injury, but it's better if we can just be able to select all the pedestrian crashes. And so as you go through that, those are just ones you're going to skip over and not be crash typed. And then there's some others that end up that are, I think, as I mentioned before, that may actually be a bike crash when they're coded as pedestrian and vice versa.
And this is Achilles. I echo Mike. In fact, I have numbers here. About 10% of the possible injury, no injury crashes are actually not pet bike related at all. And it's just the officer doesn't have any other way of saying that this person is not a driver, and they're just putting them as a non-motorist pedestrian, really, in our case. And in fact, we do have law enforcement academies involved where when we do identify problems with the crash reporting, we do go back to them and say, okay, this is how you need to be improving how officers complete the crash form so that data is more accurate. In fact, most of the time, the description itself provides a lot of information, but it's obviously the main thing that's missing from the database. Otherwise, you just have all the variables that are coded. So we find that reading the description and looking at the diagram more than actually looking at the rest of the information, let's say, provides a lot more information and more accurate description of the crash itself than looking at what they coded as the type of the crash. Because again, remember that the type of crash at that point, usually the report just says pedestrian crash. That's it. It doesn't say anything else. So we do tie back and go back and try to improve the data quality that comes in.
No, that's great. That's excellent. Michael Sanders in Arizona, I wanted to ask you, you started off your presentation talking about these plans that are really being informed by the data that you're typing in Arizona, the bicycle and the pedestrian safety action plans. And you spoke about using that opportunity to address not only high crash, but high risk areas. And the whole purpose of this typing exercise is really to get at a better countermeasure selection. And so I'm wondering if you can share a little bit of information, maybe high level stuff about on the high risk side, maybe a systemic way of addressing pedestrian and bicyclist safety. What countermeasures are you looking at that might allow you to do that for bicycle and pedestrian safety? Not necessarily a high crash approach, but a high risk. I'm really interested in that strategy.
Well, I mean, it's not unlike the high crash, because we can identify similar roadway characteristics. I mentioned the example of single point urban interchange, where we can begin to make some recommendations that would, address a facility type that's going to address a pedestrian safety problem. Brent mentioned the turning radii. So, it's just really another set of locations for us to look at to try and work that into a project so that we can prevent the crashes from occurring to begin with. The other things that we've been doing is going into our 5-year construction program, identifying existing programmed projects and seeing if we can't piggyback on top of an existing project, whether that would include, adding a median to one of these areas that we've identified as high risk, so that we've got some pedestrian refuge that would address the crossing road crash problem.
That's great. No, I think we'll look forward to seeing how some of those projects unfold, and I'd recommend anyone go into those plans and checking them out. I think there's a lot of really good recommendations there, and based on really good data, sort of as we've heard. Unfortunately, I'm sorry to say that's the last question we'll be able to take as part of the Q&A, but a lot of you have questions, really specific, detailed questions about these various systems that have been developed and have been shared today, and I'd encourage you to reach out to our panelists who may be able to share more detail about how these are set up and what they do and how they operate. Their email addresses are here, and please reach out to us if you would like us to forward your question. I'd be glad to get an answer to those. I want to remind everyone that you have an email coming later today with a lot of the archive information from this webinar, the recording link, all that's going to be in one place in your inbox in about an hour. We're also going to be sending out that link to generate your certificate of attendance with that same email. So be on the lookout for that. Pass it to others who are attending with you. We'd appreciate your thoughts on our webinar today in the survey that's going to greet you as you exit. So take a moment, please, and let us know what you thought. Let us know if there are other topics or other comments you have about expanding on this or expanding on a different issue, something you would like to learn about. And I just want to say thank you again to our entire panel for delivering presentations today. And thanks to all of you for attending the webinar. Have a great day, and we'll see you next time. Thank you very much.